Chapter 1, Lesson 5 of Pre-Calculus, we looked at parametric relations, and now we're going to look at inverse relations and inverse functions. And this is where we will spend most of our time in this lesson. An inverse relation, or inverse, is where the x values of a relation become the y's and the y values become the x values. So you're switching the domains and the range. Again, this is pretty simple. The x values become y and the y values become x. Graphically, what it looks like is it's a reflection over the line y equals x. In other words, if you were to sketch the graph y equals x on your graph, and then you would reflect it over, you would take any values over on this side and reflect it over this side and vice versa. That would give you your new relation or your inverse relation. Now, there are some things we want to consider when it comes to this, some deeper questions we want to look at. Some things you'll want to address in your summary. Will a function's inverse always be a function? In other words, if you have the function y equals x squared, will its inverse also be a function? Can a function have a relation as an inverse? Or do you have something like this, that when you do the inverse it then becomes a relation rather than a function? Or if you have a relation, something that's not a function, will its inverse also be a relation, or will its relation be a function? So these are some of the questions we'll want to answer as we look at this lesson and as we go forward. You remember we have a vertical line test to test whether a graph is a relation or a function. We have the horizontal line test, and what the horizontal line test does is to show if the inverse will be a function. So we can take a function and we'll do the horizontal line test. We'll look pretty much for the same thing, only we'll do it for the horizontal. If it crosses the graph in more than one place, the inverse will not be a function. If it crosses the graph in only one place, this is a function because it passes the vertical line test and it also passes the horizontal line test, so the inverse will also be a function. So we can use the horizontal line test to determine if the inverse will be. And if the inverse will be a function, then the function and its inverse are called one-to-one. So if we refer to an equation or a function and its inverse as one-to-one, what that means is both the original function or the original relation is a function, and also the inverse will also be a function. So if they're one-to-one, a function or a relation will pass both the vertical line test and the horizontal line test. And we have this notation here, f negative 1, it looks like negative 1 of x. And we read that f inverse of x. And again, this will be important notation to note, especially when we're considering domains, because if we're looking again at the domain of an inverse, it is going to inherit some characteristics from the original function. So if you don't put this notation, and it looks like we're just looking at a function independent of its origin, then the domains might not seem to make sense to us. So we'll want to make sure we use that notation. Now, how do you determine an inverse graphically? Again, we talked about it already. An inverse is a function that's reflected over the line y equals x. And we know from our definition that the x values will become y and the y's become x. So what's that mean is the x values that are positive here, that are in green, and the positive y values that are here in blue. I probably should have used some more drastic colors. But an inverse means that the x's become y and the y becomes x. So visually what you'll want to do is think about this green positive x-axis has to become where this blue one is, and this blue y positive has to go where the green one is. Well, in order to do that from a picture, you got to think about turning this clockwise, and so now we have the positive y's are the positive x's, but we don't have the positive x's as positive y. We have them as negative. But we can fix that by flipping this over. And now you can see that these that were once the positive x are now the positive y's, and these that were the positive y's are now the positive x's. So graphically, or visually, that's what it looks like, and that is actually reflecting everything over the line y equals x. So if you drew a line down here, line y equals x, and you measured all these points on this side and reflected them over, that's what you would get. So you'll notice this is a function. It does not pass the horizontal line test, so we know the inverse will not be a function, and visually you can see that, because when we make the y positive x and the positive x positive y, you'll see now that the inverse does not pass the vertical. And basically what you're doing is you have a horizontal line. When you turn it, it becomes the vertical. So you can see why we can do the horizontal line test and figure out if the inverse is going to be a function or not. So that's what it looks like graphically. So you can turn the graph clockwise or counterclockwise, and then you'll have to turn it over in order to get that positive x to become the positive y. But graphically, that's what it looks like.